When providing temporary electrical service to an office trailer with a 480 volts, 80 amps single-phase supply over a distance, proper grounding is crucial. According to the National Electrical Code, all electrical systems must have a grounding path to earth. This grounding path provides a return path for electrical current in the event of a fault or surge, protecting equipment and personnel from electrical shocks. In this situation, a ground wire must be run from the panel in the building to the trailer for several reasons. Firstly, equipment grounding is essential. The neutral conductor created at the trailer by bonding EXO, the transformer's neutral output, to the trailer frame only provides a current return path for the secondary, that is 120/240 volt circuit, not the primary 480 volt circuit. It does not provide a grounding path for equipment within the trailer. Secondly, a fault current return path is vital. In the event of a fault in the primary circuit, the ground wire provides a low resistance path for the fault current to return to the grounding source, which is the electrical panel in the building. This prevents high voltage from developing on the trailer and potential electrical hazards. Thirdly, the ground wire also serves as a lightning protection ground. In the event of a lightning strike, the ground wire provides a path for the lightning current to flow into the earth, protecting the trailer and its occupant. The National Electrical Code requires the ground wire to be sized according to the rating of the primary phase conductors. For 80 amps primary conductors, the minimum ground wire size should be based on NEC Table 250.122. For an 80 amps overcurrent device protecting the 480 volt circuit, the code stipulates specific minimum sizes for grounding conductors, depending on the material used. According to the NEC, if using copper, the minimum size is 4/0 American wire gauge bare copper or 3/0 American wire gauge stranded copper. If using aluminum, the minimum size is 250 kc mil bare aluminum or 2/0 American wire gauge stranded aluminum. It is important to adhere to these minimum sizes to ensure effective grounding. Running a ground wire with the primary phase conductors from the building to the trailer is essential for ensuring the safety and proper operation of the electrical system. It provides a grounding path for equipment, fault current return, and lightning protection. Remember to always consult the latest edition of the National Electrical Code and local regulations for specific requirements and to ensure compliance with all applicable standards. When dealing with electrical installations, prioritizing safety and adherence to established codes is paramount. Always ensure that electrical work is performed by qualified professionals who are familiar with the relevant regulations and best practices. The information provided is for general guidance only and should not be considered a substitute for professional electrical engineering advice. Electrical codes and regulations can vary depending on location and specific circumstances, so it is crucial to consult with local authorities and qualified experts to ensure compliance. In summary, the importance of running a ground wire with the primary phase conductors cannot be overstated. It serves multiple critical functions, including equipment grounding, providing a fault current return path, and offering lightning protection. By adhering to the NEC guidelines and ensuring proper ground wire sizing, you can significantly enhance the safety and reliability of the electrical system supplying the office trailer. Always prioritize safety and seek professional assistance when dealing with electrical installations to ensure compliance and prevent potential hazards. Failing to properly ground the electrical system can lead to serious consequences, including electrical shocks, equipment damage, and even fire. It is crucial to understand the principles of grounding and to implement them correctly to protect both people and property. The NEC provides detailed requirements for grounding and bonding, and it is essential to follow these guidelines to ensure a safe and effective electrical installation. Remember, electrical work should only be performed by qualified professionals who have the knowledge and experience to do the job safely and correctly. If you are unsure about any aspect of the electrical installation, consult with a licensed electrician or electrical engineer to get expert advice. By taking these precautions, you can minimize the risk of electrical accidents and ensure the safety of everyone involved. The purpose of grounding is to provide a low impedance path for fault current to return to the source, which will cause the overcurrent protection device, such as the circuit breaker or fuse, to trip and to energize the circuit. This protects people from electric shock and prevents equipment damage. In addition to providing a fault current path, grounding also helps to stabilize the voltage on the electrical system and reduce the risk of voltage surges. This can help to protect sensitive electronic equipment from damage. There are two main types of grounding systems: equipment grounding and system grounding. Equipment grounding is the connection of all non-current carrying metal parts of an electrical system to ground. This includes things like metal enclosures, conduits, and equipment frames. System grounding is the connection of one of the current carrying conductors of an electrical system to ground. This is typically done at the service entrance, where the electrical power enters the building. The grounded conductor is typically the neutral conductor, but it can also be a phase conductor in some cases. The size of the grounding conductor is determined by the size of the overcurrent protection device protecting the circuit. The NEC provides tables that specify the minimum size of the grounding conductor for different size overcurrent protection devices. It is important to use the correct size grounding conductor to ensure that it can safely carry the fault current back to the source. Grounding electrodes are used to connect the grounding system to the earth. There are several different types of grounding electrodes, including ground rods, ground plates, and metal underground water pipes. The type of grounding electrode used will depend on the soil conditions and the local requirements. It is important to install the grounding electrode correctly to ensure that it provides a good connection to the earth. Grounding is a critical part of any electrical system. It is essential for protecting people from electric shock, preventing equipment damage, and stabilizing the voltage on the electrical system. By following the NEC guidelines and ensuring that the grounding system is properly installed, you can create a safe and reliable electrical system.